Okay. Welcome everyone to the ODSA session. My name is Jawad Nasrullah. I am with Palo Alto Electron. And I'll just introduce Tony Mastroianni, who is going to tell you some really exciting updates coming from Chiplet Design Exchange work stream, in particular related to design kits. So I'll just briefly mention what we do at Chiplet Design Exchange, commonly referred to as CDX. When we started this work several years ago, we were thinking about making chiplets machine readable and defining their different characteristics such that we have interoperability in the design tools and such that we can run different types of generative algorithms to come up with systems. So that was the big idea behind it. In the last several years, we have put out a number of specifications. The most interesting one is Chiplet Design Kit, which basically tells you that if you want to sell in this economy, what are the type of collaterals that your customers will be expecting and for what reason. Last year, we put out a description of the chiplet part model that got picked up by JEDEC, and that's JEP30 standard CDXML. It's a pretty interesting progress, and it has life of its own and will have good longevity. So today we are now working on defining all the integration workflows for system designers. So look out for that. In a few months, you'll have that. And now we've started a new initiative, which is defining design kits for the benefit of manufacturers, material suppliers, assemblers, and obviously that ties into the design workflow. And that is the exciting piece where we will be spending most of the time today. If you are interested in one of those previous items, we have given talks on it. Just search and you will find details of those. With that, I'll hand it over to Tony, who will take you through this initiative. And Tony is the main lead for this work.
Okay, good morning, everyone. Again, my name is Tony Mastroianni. I'm at Siemens EDA, and I'm going to talk about 3DKs, is what we're calling them. So when I first joined the CDX group, it was about 3 years ago, and the first project that I got involved in, can you guys hear me okay? Yeah, was we were working on a white paper, and the intent was to, all right, if we want to facilitate a chiplet ecosystem, we need to have define a set of recommended models that could delivered with a chiplet. So the idea is to provide all the models that a system integrator would need for that chiplet in order to integrate that. So we published a white paper. I presented that at IEEE conference in NC State. It was during COVID. It was a pretty small crowd, and we got a lot of interest in that. So we took it to the next level, and we're calling it a chiplet design kit. So when we were putting this design kit together, there were some important tenets that we took into account. One thing is we want to leverage existing standards. If there's something out there that met the needs, use it. No sense to re-adopt it. If it didn't quite meet the needs, we could either modify that spec or we could create a new spec. So the good news, in most cases, most of the standards were available, but there was a couple that were not addressed, and that's what we worked on. We want machine-readable models. That's very important. So we want to be able to consume these models with workflows, scripts, really try to avoid PDFs as much as possible. I think the silicon industry has been embraced that mentality for many years. The package, it's going to take a little bit of work. So we're really trying to extend that same concept through all the package, substrate, et cetera. Support workflows. So we want to integrate these design kits into the workflows. And then we also want adoption by the whole ecosystem, the EDA vendors. So we want EDA vendors contributing to this. We have multiple EDA vendors. We have fabs, OSATs, all part of this team, making sure that we're representing all the needs. And there's a lot of interest. We're very actively involved in the CHIPS Act, and we have a lot of interest from different programs that we're working on, and we have collaborated with other EDA vendors to support this. So the CDKs, the chiplet design kit, is pretty much in good shape. We've released that back in January of 2023, and we have white papers on that, et cetera. So the chiplet design kit, sorry. Okay, so this is a summary of the models. I'm not going to go through this in detail, but these are the views that are necessary to integrate a chiplet into a package. You need thermal views, you need mechanical, physical views, electrical, behavioral views to support the analysis, system, signal, power integrity, et cetera. And there is some need for documentation. So most of these areas were covered. Test is important. You need to adopt the IEEE standards to be able to test these chiplets in the context within the package. But CDMXL is one area that we addressed where there were some gaps. So this is defining the detailed physical models, and also think of it as an electronic data sheet. So your operating conditions, ESD leverage, that's all defined in the CDMXL format. And then also what we did in the CDXL format, all these other views, we kind of have a checklist. So as a part vendor is trying to deliver that, they can show what models are available for each of these chiplets. So the CDMXL format specifically covers, it's a common data exchange format. We're using an XML schema. We do include definitions of the standard industry chip-to-chip and die-to-die interfaces. So for the chip-to-chip, BO, UCIe Express, XSR. So we have some common naming in there for those pins. So when you're mapping your chiplet, you may not necessarily be using the industry standard term, but you can map that, and then that could be used for generating connectivity and all sorts of good things. Again, as I mentioned, electrical information, the I/O information, you're going to need specific definition of the type of I/O. Is it a micro bump, a ball, the dimensions? All of that is defined in this format, and there's power and thermal information. So we just had a press release. This is not the latest. There was another one a couple of weeks ago. But the JEP30 Part Model initially was targeted to define components that would be used in a system, primarily targeting PCB integration. So what we did when we started developing the CDMXL, we talked to the JEDEC folks and said, we'd like to extend that format to address chiplets. And they said, that sounds like a good idea, so they agreed to that. So we really focused on the stuff specifically necessary for a chiplet. There was a lot of infrastructure that we could leverage from JEP30, but there was a lot of stuff unique to what we needed. So that is a separate subsection that's in the JEP30 model. The other thing is this part model can be used to provide a kind of an ecosystem for a marketplace. So chiplet providers can provide all the information for their chiplets, and then think of it as an electronic catalog, and users can actually query that to see what functionality is there. They can get some of the information physical and learn about those parts. And then there are some views that can be used to actually do some early prototyping and planning. And it could also be used as a commercial mechanism also. We're looking into possibly having supply chain links into this. So once those chiplets are out, you can get visibility into the availability of those chips and the whole ecosystem in the supply chain. So I think we did a pretty good job on defining what is required for chiplet models. The next step is, what do the system integrators need? Okay, so we start, they have all the models, but the other things that we need are these design kits. So there's a couple of programs, government programs, where they were looking for assembly design kits. The DARPA NGMM program, they were looking for 3D assembly design kits. So that's, when you think of assembly design kits, you're thinking routing rules. But we took a broader scope and said, what are all the models that are required for this system integration? And we took some poetic license and called it a 3D IC design kit. So DARPA actually called something similar 3D IDKs. So that kind of, again, we were collaborating with other EDA vendors, and we agreed, let's work together and let's do it in an open forum. So that's why we're doing it in OCP. So the 3D design kits include the CDKs, which I talked about. And certainly when you're doing these types of systems, you do need your SoC IP. These are your models for your SoC libraries and process design kits. Again, very well established, but some of those views are necessary when you're doing the chip integration. System and package, or SIP, design enablement does require an additional set of building blocks. And that's really what we're trying to do with the 3DK, is a comprehensive set of proposed design enablement kits. And I'll talk about each of these briefly in a few slides. So we've talked about the CDKs. The next one is the SoC libraries. So when you're doing the chip integration, you're really looking at what I call the front-end views. So these are the left, the libs, the system, and Verilog models. Because when you're doing your floor planning, you need to make sure these things are physically represented. Now, with the CDXML, we can do the same thing as well. But we have simulations. These are all views that are included in the chiplet as well. So these can be used for physical planning, and it could also be used for some architectural exploration with some of these models. The next one is process design kits. Now, process design kits have been established for many, many years in the semiconductor industry for ICs. So this includes technology files, DRC, LVS, extraction rules, and then you have circuit design kits for analog and memory. Silicon interposer is really a subset of that, so that's pretty much covered. It's basically a silicon process. What we're trying to do is extend the same concept to organic substrates and the packaging world. So again, rather than having PDF documents for DRM, we're establishing formats to be able to describe the rules for these, everything that's within the package, not just the silicon stuff. Now, the next category here, we're calling it package assembly design kits, PADK. So this has three main components. One is to support the planning process, you need the physical models, and essentially the models in the CDXML, that's kind of covered, so they come with the chiplets. And then you need to define the stack-up information. This is how the chiplets get integrated into the package. So it's the XYZ placement of those objects, the orientation, whether or not they're flipped, rotated, so all of that is encompassed in what I call 3D IC stack. And then the other category kind of falls into package design, assembly design rules. So these are the rules on how this interconnect is going, spacing, width, that type of information. And then there are some higher level rules that may be more related to the package. So things like spacing to cavities and such like that. So all these models in the OCP, and the philosophy of OCP is to have open models so that they can be accessible by users as they need, but we do want to eventually make them standards, and it'll be in a controlled release. So they're available for people to use now as they're being developed, but it's kind of use at your own risk, and eventually once they become JEDEC standard, they'll be available and support it. The other thing is material design kits. Again, so this is coming up with a neutral format to describe all the material properties that would be used in the different analysis, signal, power integrity, and such. So we have two initiatives that are actively working on the MDKs as well as the PADKs that I talked about. The last one here is, this is more of a best practice. So the idea is to kind of centralize a library of the connectivity building blocks, and you'll have the views associated with that. So when you have multiple chips from different vendors and different assemblers, you want to make sure that everyone's using the same connectivity and it's consistent, and we put that in the library. So there's no standards per se, but it's more of a best practice. So in summary, we really need to, these are the workflows here, and these are all the design kits, which really enable the design of all these chips. And we're really going from the architectural definition all the way to release to manufacturing. So if you're interested, we have lots of white papers. I have some links published here. We do have a weekly meeting where we just have a general meeting on CDX. That's where we work on white papers and such. We have two groups that we alternate every other Thursday, one working on the 3DKs and the other one working on the MDKs. And again, if anyone's interested in joining us, just reach out to David Ratchet. He's out in the back corner, and we'll get you. You could just sit in and listen. If you're interested and want to work with us, that's great. And we also have some demos set up. If you want to see some working prototypes of some of these formats, come out to the Experience Center and take a look. And we can address any questions out there if need be.
You got 2 minutes for questions if you like.
Oh, okay. Questions?
Hey, Tony, quick question. Does any of this address the ESD requirements?
Yes, in the electrical section,
Okay.
we describe the ESD properties for each of the pins. There's a mechanism to do that.
Because the ESD is, I mean, between 3D stacking and 2.5D, it's different, and then it may also be dependent on where you're getting the assembly or the foundry process, right?
Well,
How
the
do you
idea
address
in the CDXML for the chiplet, it rates what ESD has for that I/O. You know, actually checking ESD in the package is a different problem. That's really more of an EDA problem.
Okay, so yeah, I was looking at kind of the die-to-die interface.
Yeah.
Because there are some ESD requirements.
Yeah, so whatever ESD level is supported would be defined. There's provisions to define what your coverage is and then the conditions in the CDXML format.
Okay, thank you.
Yeah.
Go ahead, please.
So appreciate the addressing of test requirements
Yes.
and test process as part of the overall workflow.
Mm-hmm.
Is the testing perspective at this point more from a manufacturing point of view or for a design verification point of view? And are they both adequately covered?
Well, specifically when I talked about test here is for ATE testing.
Right,
And again, there are IEEE standards that support that. We strongly encourage that those are used. In the CDXML, we're basically providing a mechanism where the chiplet vendors can say, we're using this DFT method for this. And again, it's possible they can deliver the patterns and scripts in there if they choose to. More realistically, that'll probably be a relationship that they'll have directly with the end users. For functional verification, we have the Verilog models, so they could be used from that perspective for functional verification.
Okay.
One thing I didn't mention, the PADKs, we also have provisions that describe pins for wafer sort. So that's in this PADK as well. Okay, thank you.
Thank you. Next speaker is oh no, for sure. So we're graced by Chiplet, the first man who first created chiplets in the founder of Model is here with us. So we're all following the roadmap.